Our third presenter today, and our second for this session on new surveillance from above, is Paul Adams, Director of Urban Studies, Department of Geography and the Environment at the University of Austin, Texas. Paul's talk is on surveilling climate change from above. Paul, the floor, such as it is yours.
Thank you. Thanks to Astrid and to the Viz Media team. So we can go ahead and start the slides now. So my talk is remote but engaged, thinking about the way that the remote view of the planet may help promote a sense of engagement with environmental change. So one way it does that is by serving a huge amount of information in a way that's very quickly processed. So what we can see here is the climate change captured in a large number of images of the heat of the Earth. Next slide. So work by Maxwell Boykoff, who has focused his career on this topic, points out that visual imagery can increase our sense of engagement with the topic. It can provide a huge amount of information in a very compact fashion, and it can have what we call affective power, moving people emotionally. And in the case of environmental change, that is a very important issue because many people feel disengaged and they don't see this as a top priority. Next slide. So the remote view of the Earth from space is becoming our reality of what the Earth is. And to the point that it's hard to explain, and it would take 20 minutes or 30 minutes with a classroom to help the students separate the reality of the Earth from our visions of the Earth. And this is just one example of an image that is reconstructed from digital data that was captured from satellites. Next. So Astrid and I, many years ago, as a result of an earlier research visit in Norway, did some research on how people received and responded to information about the environment that was being delivered in various forms. And we found that there could be some weaknesses. We weren't looking at remote sensing at the time, but we found that people have a strong sense of local attachment, and it's important to try to speak to that when changing their environmental attitudes. And we found that it helps when people are engaged with images rather than just viewing static imagery. And so in both of these ways, there's maybe a caution about using remote sensing images to try to change people's attitudes about the environment. Next slide. So that cautionary note runs all through social science. Next slide. For example, if you read Paul Virilio's book War and Cinema, it conveys the idea that there's some sort of a deep level of connection between film and video and warfare. Next. Interesting collection of research by John Pickles. It's now very dated, but nonetheless interesting, called Ground Truth, looks at GIS, which is the use of computers to process digital data in map-like form. And he finds a sort of Foucauldian connection between the power of that imagery and other forms of social power. Next. A more recent book by Dennis Cosgrove called Apollo's Eye critiques the tradition of looking at the world as a whole and links that to ways of asserting authority. Next slide. So there are many more examples in the literature, and it's something to be aware of when researching the topic of remote sensing imagery, is that social scientists have critiqued this sort of a gaze from above, a panoptic gaze, an omniscient gaze that that has some claim to power. So despite all of this, next slide. However, next, assuming that these images of climate change are potentially helpful, next, and that the question is, what can we learn from this for journalism? Next. First of all, stepping back, let's think a little bit more about what remote sensing is. Next. So the part that we are most familiar with is the satellite, of course, and the idea that it is taking pictures of the Earth. So this image sort of captures what I think enters most people's mind when they think of remote sensing. Next. But it is an artificial way of seeing the Earth, or a constructed way of looking at the Earth. So the picture on the upper right is using real colors, as you would see them if you were in a space station, let's say. The other three pictures are actually more typical of the analysis of remote sensing images. And here what we're seeing is a remixing of bandwidths in different combinations to bring out details that relate to what's going on the surface of the Earth. So remote sensing images actually require a certain amount of background information to be able to interpret and understand. Part of that learning has to do with learning what the different ways of mixing bandwidths are and how that brings different things to being visible. Next. And here we have the huge panoply of things that are up in the air that NASA is operating, that's providing imagery. So it's not just a certain line or brand or type of satellites, but it's many different kinds of satellites, even just used by NASA to measure all different sorts of things, including temperatures and soil moisture and many other things that these satellites can see. Next. ESA, their Copernicus program is also surveilling the Earth to measure environmental change. Next. And to understand remote sensing, then we can't just think about a satellite. We can't just think about the taking pictures, because they're not just pictures. There are multiple bandwidths that are remixed in various ways by various people for various purposes. I can't go into everything that's on this diagram. The basic point of it, though, is that remote sensing is actually a network of different things that are interconnected, including particular kinds of actors who are collecting information, reusing information, processing information. And these are all intersecting with journalism. Click, please. So journalism is itself an actor network. So to understand the journalistic interaction with remote sensing, we have to think about two networks that are interacting, networks of technologies, visualities, discourses, actors, and practices in both cases. Next, please. So in short, then, to understand remote sensing, we have to think of it as heterogeneous elements, various things that are not the same as each other. These are producing novel ways of looking at the Earth and perceiving what's happening on the surface of the Earth. These different ways of looking at the Earth are being orchestrated by various actors, and they're creating images that are occasionally incorporated into the news. And I emphasize occasionally because there's a lot more good imagery being created than shows up in the news. The news brings in a very small percentage of what's available that could be turned into news stories. Next. So if you are a journalism professional, where can you find these images to use? If you're a researcher, where can you find these images to study? Turo has outlined more sources. I'll just give a couple examples. Next. So Copernicus has an open access hub. It produces an enormous amount of images. You can see on the part that I've highlighted there, it says 31,838 products published in the last 24 hours. So this is an absolute flood of potential imagery, but it's very hard to figure out what to use. Next slide. NASA has a free resource, the Earth Observatory, which processes the images more. It's a lot more selective, and it gathers and categorizes the images for easy use. So it is a very sort of a publicly oriented source for these images. It's designed for news media and for research. Next. On the Earth Observatory, you can pick a topic, and it will generate a large array of different options that would fit that particular search term. So here you can see a bunch of results from a particular topic. Next. And when you look closely at any of these particular options, what you see is the image, but also a set of different categories that image would be associated with. So in other words, it's a large sort of networked system of classifications that they're using to organize the images. And then if you click on the title of any one of these images, it'll bring up a bunch of information. Next slide, please. So here's an example of the information that could be brought up by clicking on a particular image that has to do with Siberian warming. And as you'll see, this is not a visual image. I mean, it's a visual image presented to us, but it wasn't captured in visible wavelengths. Data was captured and then processed in order to produce what we call a thematic map. So the map then is accompanied by a detailed explanation with links to various other pages and much more detailed explanations of what you're seeing. And I think this is an absolutely essential component of any kind of remote sensing data. It requires a fair amount of explanation for the viewer to understand what they're seeing, because there are so many ways to see it, so many ways to process the initial data, much of it outside of our visual spectrum. So we're talking about infrared and ultraviolet, or mixing combinations of wavelengths in ways that the human eye doesn't see. So the explanation is required, I think, to have journalists be able to make sense of it, and it's there. So Earth Observatory is a great resource. Next slide. But it also presents a research puzzle to try to figure out how useful has this been. NASA doesn't have the human resources to keep track of when its images are being used or how they're being used. This I found astonishing. It was sort of the first point in this research project where I found that they couldn't give me any information because they didn't have it. They produced the images and the accompanying text, but they don't really know how much of it is being used or how. So it would be very, very interesting to know what sorts of images tend to go viral, and specifically, how do they go viral? What sort of borrowing is happening from one source to another to another? For example, as Turo mentioned, New York Times can be seen as taking the lead. Sometimes, if they promote a story, then other journalism, other news sources will pick up on it. But they're certainly not the only news source that will do this and then cause others to pay attention. So there's a puzzle there to understand how this imagery is being used. Next. So unfortunately, I haven't taken the research project farther than this. I've identified that this is a puzzle to solve. My plans are in spring and summer to begin looking at this process. And that brings me to the next slide, which is, how can you figure out when the images have been used? This, fortunately, depends on another technology that is in place, and that is image search online. So Google will allow you to upload an image and then search for every website that uses that image. It's a Google image search. And it has its strengths and its weaknesses. The weakness is that it brings in a lot of different images. It's not very selective. The strength is exactly that you can see all the sites that may have used the image. But something called TinEye, which I have shown a screen grab from on the right, TinEye will only return positive hits on sites that are actually using that particular image. It's very specific. Next slide. So using this story then to see where it went. Next slide. TNI returned 70 sites that were using this image, 70 results, and click, please. Here are those sites boiled down, and as it turns out, it's not really 70 because many of them were using the image multiple times within the site. For example, if you want to link to the story from some other part of the site. So when you boil it down, you get Washington Post, NPR, that's National Public Radio, BBC, The Guardian, Daily Mail, so on and so forth. There were major news sources. There were online news sources of specialized interest. There were different international organizations. It was just a very interesting collection of different groups using this imagery. It really kind of went viral. Next image. Sometimes they don't go viral. This particular one, which also arguably was just as useful for news, did not go viral, had 0 matches. No one used it. And I find this very fascinating. Now, this was published on January 6th. There were other things happening on January 6th. American news media were a little bit preoccupied on January 6th because we were having our mini revolution of 2021. And unfortunately, that drowned out all the other news. It's been hard to find out anything about anything in the US except for our difficult political situation. Next slide. So this can obviously produce results that reflect other news, and it's about the context of news, and any analysis of the effectiveness of remote sensing images in the news has to take into account that these are interacting with other news that's happening at the same time. Next slide. So just some final thoughts to wrap things up then. The political and ethical concerns with surveillance are something we always need to keep in mind, even if we are advocating the use of a form of surveillance to understand the Earth's environment and how it's changing. There are some questionable purposes for remote sensing. So as we become more and more dependent on it, and it becomes more and more part of how we understand the planet, we have to become even more aware of the potential harms caused by this form of surveillance, and as it becomes more pervasive. We also have to be aware that this is a distant and abstract gaze, and a certain segment of the audience doesn't care. They're not interested. I've worked with people in my research who say, the Arctic is far away and it doesn't bother them if it melts. They don't mind. They don't care if the polar bears go extinct. This is a very common attitude in rural parts of the United States where I've done research. They're interested in something that might affect their hometown. So this is an issue to keep in mind. Remote sensing imagery doesn't solve all the problems that we face with getting across climate change messages. And finally, I still believe that if we can better understand how these images are being used, and if we can track them, then we'll understand how to bridge the gap between earth science on the one hand and journalism on the other. Thanks.